Now let's talk about MLPs with seasonal indicator or dummy variables. So we're going to look at this just going through the code in the book. We'll start up here where we're defining the cardiac train and the cardiac test. We're going to let the train go from 1970 to the 40th week in 1978, and the cardiac test to pick right up there in the 41st week in 1978 and go to the 40th week in 1979. Remembering this is weekly data. But in order to forecast the cardiac mortalities, we have explanatory variables, the temperature and particulates, which we also wouldn't know in the future. So we have to forecast those as well. So what you'll see here is just stepping through that code. That is a model to forecast the temperatures, and we see this is that model. So there's the fit.mlp.temp. That's the makeup of the model, a bunch of univariate lags, which is what you see right here. And when you plot it, that line right there is this plot right here. And then we're going to actually do the forecasts and plot the forecasts. And here are those forecasts. So look pretty reasonable. Temperature forecast, we can see the median, excuse me. Right, the median is what is being used there to summarize all of those 50 repetitions, those 50 repetitions you see there. Then we do the same thing with the particulates. So from the particulates, we have fit.mlp.part, again with 50 repetitions, and combining them with the median. We look and see we have this type of model right here with all those inputs. Those are just univariate lags. And when we plot the forecasts, which we do right here, plotting the forecasts, we can see we also, again, use the median, which is ignoring these really rogue kind of extreme values that might pull up the mean, that would pull up the mean a little bit more. We're again taking the median. So at that point, we have forecasted the next 52 temperatures and the next 52 particulates. So now we're ready to box them up in a data frame, which is what we do right here. So we're putting in the data frame the temperatures and the particulates, so that notice we're putting those into cardiac df underscore xreg, and we're going to send them off to forecast the cardiac mortalities. So note that we're building a model here for cardiac mortality. We're giving it the training data so that we can leave some off the end, a whole year off the end to do. We don't have a rolling window MSE right now, a rolling window RMSE right now for MLP models with exogenous variables, just for univariate models. So we'll just hold off the last 52 to evaluate and get a cross-validation statistic. So here we have this model that's given train. Again, we've got a seasonality of 52 that'll help choose those univariate lags. Reps of 50, we're going to combine using the median, and here's where we pass it the cardiac df underscore xreg. That's where we're going to give it those temperatures and particulates that we forecasted earlier. And we're here. We are not going to allow the seasonal dummy variables, which this whole video is about these seasonal dummy variables. And we're going to show the value, the potential value of those here. So this model here is, note that it's got two sets of exogenous variables. Those are going to show up as blue in the neural network model. So those are the exogenous inputs. Those are the univariate inputs. And how well did it do? So it looks like it had an RMSE of 7.00397 on the holdout 52, on the last 52. And here were the forecasts of those last 52. So again, using the median of these quite variable repetitions, we come up with, again, a 7.00397 RMSE when we don't use the seasonal indicator variables. Now, the seasonal indicator variables here, if you note, well, we'll see those here in a moment. Let's just run through the code. So here we have, we're going to box up the cardiac df-xreg again, just the same as we did before. But now notice that we're going to, everything's going to be the same except for when we're doing the cardiac. Notice I'm saying that's fit.mlp.cmore-s, because we're going to add the seasonal indicator variables here, the seasonal dummies. Notice we have allow.deterministic seasonal variables true, and that we're going to use the binary type. There actually is a trigonometric type that is pretty interesting that you can look into, but we're just going to look at the typical indicator variable. And for 52 weeks, we need 51 indicator variables. and the last one, the 52nd week, will just be 0 for all 51, and exactly one of them will be turned on at one time unless they're all 0. So it's just your typical indicator variable that it indicates, that can tell the model what week you're in, because it's seen that week 7 or 8 times throughout this many years. 1, 2, 3, 4, 5, 6, 7, 8 years. So what we'll see here is that it has some additional inputs. Notice it says deterministic seasonal dummies included. So I will go ahead and show that. That's what these red ones are. So this is quite a complex model. It's got one hidden layer with 5 hidden nodes. It's got univariate inputs. It's got exogenous inputs, and it's got these 51 seasonal indicator variables inputs. So in each of those, there's 51 of them there, and they're either 1 or 0 depending on what week we're in, or 0. All of them are 0s if we're in the 52nd week. Great. So did that help? So let's look at the forecasts, and we look at the forecast there, and those forecasts look different. Notice we took the median, thank goodness, because we had some extreme values that would have really dropped that down. But again, when we did this, we looked here and took the medians, right? So we were taking the median of those, and if we scroll down, notice it was 7.00397 without the seasonal indicator variables. And now with them, it is 6.203129. So subjective, but seemingly a pretty significant drop in the RMSE for the last 52. So the big takeaway there is you might decide to move forward with these seasonal indicator variables. And that's what we did. So great job. This is a look at kind of summarizing a big idea of exogenous variables, seasonal indicator variables, why to take the median over the mean, and this idea of evaluating on the final 52 with an RMSE, with a cross-validation type statistic. So lots of fun. Get out there and play around with it. Great job. Hope you're having fun.